Something is eating your garden and you don't know what it is or when it happens or how to stop it. You go out in the morning and the leaves that were whole yesterday have holes in them today, and you stand there trying to figure out whether it was slugs or caterpillars or aphids or something you've never seen. And eventually you go to the garden center and buy a spray bottle of something with a warning label that makes you vaguely uncomfortable using it near food you're going to eat. And you spray it, and it works for a few days, and then whatever was eating your plants either comes back or something different arrives to take its place, and the cycle starts again. I did this for years. Bought the sprays, read the labels, applied them on the schedule they recommended, watched the problem reduce temporarily and return reliably, and at no point did I stop to ask why the problem kept coming back despite the treatment. The answer to that question is the reason this video exists. Chemical pest control treats symptoms. It kills the insects that are present at the moment of application and leaves the conditions that attracted them completely unchanged, which is why the problem returns. The approach I'm going to give you today works differently at the root level, literally and figuratively, because it changes the conditions that make your garden attractive to pest insects in the first place. The absence of natural predators, the monoculture planning that makes it easy for pest populations to build, the lack of aromatic chemical signals that interfere with pest navigation. 15 plants, every one of them chosen because the mechanism by which it protects your garden is documented in peer-reviewed research rather than gardening folklore. And the distinction between those two things is something I'm going to be specific about as we go through the list. I want to tell you right now that number 11 is the plant I held back from including in this video for the longest time, because its pest control mechanism is so counterintuitive. It works by attracting a specific pest rather than repelling it in a way that protects your other plants, that I wasn't sure I could explain it quickly enough to make it convincing. By the time we get there, I think you'll understand why I changed my mind. First, drop a comment right now and tell me what the worst pest problem in your garden is. Not in general, specifically. Aphids on roses, cabbage worms on brassicas, squash vine borers, Japanese beetles, slugs, spider mites, whatever it is, name it, and tell me what state you're in. Because the pest pressure in a Zone 5 garden in Michigan is genuinely different from the pest pressure in a Zone 8 garden in Georgia, and the specificity of your problem determines which plants on this list matter most for you. Before the list, the framework that makes companion planting work rather than just adding plants to a garden and hoping for the best. Pest management through companion planting operates through 4 distinct mechanisms, and knowing which mechanism applies to which plant is what separates a companion planting strategy that works from one that looks good on paper and does nothing measurable in the garden. The first mechanism is chemical repellency, volatile organic compounds released by aromatic plants that interfere with the olfactory navigation pest insects use to locate host plants. The second is predator habitat, providing the specific structural and nutritional requirements that beneficial predatory insects need to establish breeding populations in your garden, rather than just passing through. The third is trap cropping, deliberately planting a preferred host for a specific pest, in order to concentrate that pest in one location where it can be managed, protecting the plants you actually care about. The fourth is physical disruption, ground-covering plants that interrupt the soil surface movement patterns of crawling pests and the soil conditions that certain pests require for egg-laying and larval development. Every plant on this list works through at least one of these mechanisms. Several work through 2 or 3 simultaneously. None of them work through the vague and unverifiable mechanism of good garden energy or companion planting folklore that hasn't been subjected to any controlled testing. If the evidence is weak, I'll say so. If it's strong, I'll cite specifically where it comes from. The first plant on this list is one where the pest control evidence is among the strongest of anything I'm going to give you today, and where the mechanism is specific enough to be genuinely surprising even to experienced gardeners. Tagetes patula, French marigold, produces alpha-terthienyl from its roots, not from its flowers, not from its foliage, from the roots, directly into the surrounding soil. Alpha-terthienyl is a thiophene compound that is toxic to nematodes. the microscopic soil-dwelling worms that attack the root systems of tomatoes, peppers, potatoes, and many other vegetable crops, causing wilting, stunting, and yield loss that is often misdiagnosed as drought stress or nutrient deficiency because the damage happens underground and is invisible until the plant is already significantly compromised. The research on French marigold and nematode suppression is not folk wisdom. It is documented in peer-reviewed soil science literature, replicated across multiple university extension programs. And the finding is consistent. French marigold planted as a dense interplanting in beds with nematode-susceptible crops reduces nematode populations in the immediate root zone. The effect is cumulative, stronger in the second and third season than the first, and it persists in the soil after the marigolds are removed, which means the soil biology you are building with a marigold interplanting continues protecting your vegetable crops after the marigolds themselves are gone. Beyond nematodes, the volatile compounds from marigold foliage have demonstrated repellent activity against whiteflies and aphids in greenhouse and field trials. Hardy as an annual across all American growing zones. Plant densely, 1 marigold plant per 2 to 3 square feet of bed space, and plant them before or simultaneously with the crops they are protecting, not after a pest problem has already established. The second plant is for the specific and extremely frustrating pest problem of aphids, which are the pest that appears most commonly in gardening questions and which have a population dynamic that makes chemical control particularly ineffective. Aphid populations double every few days under favorable conditions. A colony of 20 aphids on a rose stem on Monday is a colony of several hundred by Friday, and a spray that eliminates 95% of the population leaves behind enough survivors to rebuild the colony within a week. The approach that actually works against aphids long-term is not killing the aphids present. It is establishing the natural predators that keep aphid populations below the threshold where they cause significant plant damage. Achillea millefolium, yarrow, is one of the most thoroughly documented habitat plants for aphid predators in the entomological literature. The flat-topped flower clusters, called corymbs, provide a landing and feeding platform that is specifically accessible to the small parasitic wasps, lacewings, and hoverflies, whose larvae are the primary biological control agents for aphids in garden ecosystems. Research published in the journal Biological Control documented that gardens with established yarrow plantings maintained significantly lower aphid populations than control plots without yarrow. Not because yarrow repels aphids directly, but because it supports predator populations large enough to keep aphid colonies from reaching damaging levels. Hardy in USDA zones 3 through 9. Plant it in full sun with poor to average soil. The worst soil in your sunny beds is where yarrow performs best, which is one of the most useful characteristics of any companion plant because it occupies space that your vegetables and valued ornamentals don't want anyway. The third plant is one where I want to separate carefully between the compound that does the work and the delivery mechanism, because the nuance determines whether you get the protective effect or a plant that smells nice and does nothing measurable. Allium sativum, garlic, produces a lysine when its tissue is damaged, a sulfur compound with documented insect repellent and insecticidal activity. The key phrase is, when its tissue is damaged. Intact garlic plants release sulfur compounds from the soil-level root activity and through leaf stomata at concentrations that are detectable to insects with sensitive chemosensory systems, specifically aphids, spider mites, and certain caterpillar species that use plant volatile profiles to locate host plants. The protective effect is real but range-limited. Garlic planted within 12 to 18 inches of susceptible crops, roses, tomatoes, peppers, provides a chemical disruption in the immediate vicinity. Garlic planted 3 feet away provides little to no detectable effect on pest navigation. This is the mistake that most companion planting guides make when they say plant garlic near roses. Near means within arm's reach, not in the same general area of the garden. Hardy in zones 3 through 9 as a perennial bulb that naturalizes from bulbils. In most American gardens, it is grown as an annual crop, but if you leave a percentage of the bulbs in the ground after harvest, the resulting naturalized planting provides pest disruption chemistry alongside the ornamental value of the flowerscapes in late spring and the visual interest of the dried seed heads in summer. The fourth plant is for the cabbage family pest problem that causes more vegetable gardening frustration in the eastern and midwestern United States than almost any other single pest issue. Imported cabbage worm, Pieris rapi, and cabbage looper, Trichoplusia ni, are the two caterpillar species that can devastate brassica crops with a speed that is genuinely alarming. A broccoli plant that looks fine on Monday can have its leaves reduced to skeletal ribs by Thursday. Nasturtium tropiolum majus works against cabbage worm through the trap crop mechanism, and the research behind it is specific and well documented. Cabbage worm moths show a strong preference for nasturtium as an egg-laying site over brassicas when both are present in the same garden. Planting nasturtium as a perimeter crop around brassica beds concentrates the egg-laying on the nasturtiums, where the resulting caterpillars can be identified and removed in one location, rather than searched for across an entire brassica planting. Technically an annual in most American zones, growing as a short-lived perennial in zones 9 through 11. The mechanism requires dense planting of nasturtiums around the perimeter of the brassica bed. Not one or two plants, a continuous border, and requires inspecting the nasturtiums regularly to remove egg masses and caterpillars before they pupate. This is not a set-and-forget solution. It is a concentration strategy that makes manual control feasible for a pest that would otherwise require chemical intervention or the acceptance of significant crop loss. Number 5 is where this list moves into territory that most companion planting guides cover incorrectly. And I want to explain what the correct understanding is, because the difference determines whether you get measurable results. Ocimum basilicum 7 basil is almost universally recommended as a companion for tomatoes, with the claim that it repels tomato hornworm. The honest review of the research literature does not support that specific claim strongly. What the research does support clearly is that basil interplanted with tomatoes at high density, 1 basil plant per 2 to 3 tomato plants, reduces populations of thrips and aphids on the tomato foliage through volatile chemical interference with their host-finding behavior. Published trials from the University of Florida Extension Program documented measurable reductions in thrips populations in tomato plots with dense basil interplanting compared to tomato monoculture control plots, hardy as an annual across all American zones. Keep basil from flowering by pinching flower heads as they emerge. The volatile oil concentration in the foliage drops significantly once the plant shifts metabolic energy to seed production, and it is the foliage volatiles that provide the pest disruption chemistry. High oil concentration in the leaves requires a plant that has not yet flowered. This is the management detail that most companion planting guides skip, and it is the one that determines whether your basil interplanting is functionally active or just a culinary herb that happens to be near your tomatoes. Number 6 is one that the mosquito repellent video in this series touched on briefly, but whose role as a vegetable garden companion plant is a completely different mechanism that deserves its own treatment. Lavandula angustifolia, English lavender. In the context of vegetable garden pest management, works primarily through predator habitat rather than through direct pest repellency. The flower structure of lavender is specifically accessible to parasitic wasps in the families Braconidae and Ichneumonidae, small wasps that parasitize aphids, caterpillar eggs, and whitefly nymphs, and that require nectar sources for adult feeding before they can reproduce. Research from the University of California Cooperative Extension documented that gardens with lavender plantings adjacent to vegetable beds maintained higher populations of parasitic wasps than control plots without lavender, with measurable downstream effects on aphid and caterpillar populations in the vegetable beds, hardy in zones 5 through 9. Planted at the border of vegetable garden beds in full sun with excellent drainage. The border position maximizes the exposure of the lavender's nectar to foraging parasitic wasps moving through the garden while keeping the lavender's drainage requirements away from the consistently moist soil that vegetables prefer. This is the moment in the video where I want to say something honest about what companion planting is and is not, because the realistic expectation matters for whether you stick with it long enough to see results. Companion planting does not eliminate pest pressure. Nothing eliminates pest pressure in an outdoor garden because pest insects are part of the ecosystem that your garden exists within. And complete elimination of pest insects would also eliminate the predatory insects that depend on them, and the birds that eat them, and the broader food web that makes a garden ecologically functional. What companion planting does, when done correctly and with patience, is shift the balance, reduce pest populations below the threshold where they cause economically or aesthetically significant damage, support predator populations large enough to prevent pest outbreaks from reaching damaging levels, and make your garden a less attractive and navigable target for the pest insects that are present. That shift takes time. It takes a season to establish the predator habitat plants. It takes a second season for predator populations to build to effective levels. Gardeners who plant marigolds in May and expect no aphids by June are setting themselves up for disappointment. Gardeners who plant marigolds and yarrow and lavender and come back 2 seasons later to find that their aphid problem has become manageable. Without sprays are the ones who understood what the strategy actually promises. If you want to keep getting this kind of specific, honest, research-grounded content every week, subscribe to this channel now and turn the bell on. The follow-up to this video covers the specific companion planting combinations for the most common vegetable crops: tomatoes, peppers, brassicas, cucurbits, with planting plans rather than general plant lists. Subscribe so it finds you when it publishes. Number 7 is for the Japanese beetle problem, which is one of the most geographically specific and most damaging pest issues in American home gardens east of the Mississippi, and for which the companion planting solutions are more limited and more specific than for most other pests on this list. Geranium, specifically Pelargonium species, the annual bedding geranium rather than hardy geranium, contains geraniol in its foliage that has a documented and unusual effect on Japanese beetles. Beetles that eat geranium foliage experience a temporary paralysis lasting 20 to 30 minutes, during which they are visible and stationary on the foliage and extremely vulnerable to predation by birds and ground beetles. This is not a repellent mechanism. It is a narcotic mechanism, and the research documenting it, published in the journal Environmental Entomology, is specific and well replicated. The practical application requires planting geraniums near beetle-susceptible plants, roses, linden, grapes, and inspecting the geranium foliage regularly during Japanese beetle season, which runs June through August in most affected zones, to find and remove paralyzed beetles before they recover. Combined with the presence of insectivorous birds attracted to your garden by other habitat features, geranium planting can meaningfully reduce the beetle pressure on adjacent valued plants without requiring any spray application. Number 8 is a plant whose companion planting benefit operates entirely underground, and whose protective effect on vegetable crops is consequently invisible, which is why it is underrepresented in companion planting content that focuses on what is visually apparent in the garden. Tagetes erecta, African marigold, produces alpha-terthienyl from its roots at higher concentrations than French marigold, with broader spectrum activity against soil-dwelling pest organisms including root knot nematodes, lesion nematodes, and soil-dwelling fungal pathogens that attack root systems. The distinction from French marigold is in the concentration and the broader spectrum. African marigold's root exudates have been documented to suppress a wider range of soil pest organisms than French marigold in comparative trials. Hardy as an annual across all American zones, growing taller and more structural than French marigold, 24 to 36 inches, which makes it useful in garden designs where a border plant needs to provide visual height alongside functional pest suppression. The most effective application protocol from the extension research: plant African marigold as a dense cover crop in a bed for one full growing season before using that bed for vegetable production. The season of dense root growth and exudate production builds a soil chemistry profile that suppresses nematode populations for 2 to 3 subsequent growing seasons. This is companion planting as soil preparation rather than as in-season companion planting, and it is the application that produces the most durable and measurable results. Number 9 is for the squash family: cucumbers, zucchini, summer squash, pumpkins, which are among the most pest-vulnerable vegetable crops in the American home garden, and for which the primary pest, cucumber beetle in the East and Midwest, and squash vine borer across most of the country, causes losses that can eliminate an entire planting in a single season. Radish, Raphanus sativus, planted as a dense border around cucurbit crops, has documented trap crop activity for cucumber beetles in field trials conducted by Cornell University's Vegetable Crops Extension Program. Cucumber beetles show strong preference for radish as a feeding site over cucurbit crops when both are present. The radish border concentrates the beetles in a location where they can be managed while protecting the cucurbit plants behind it. The timing matters. Radish border planting should go in simultaneously with or slightly ahead of the cucurbit transplants, so the radish is established and attractive to beetles before the cucurbits are large enough to be significantly damaged. Radish grows quickly enough that this timing is easy to manage, 25 to 30 days from seed to usable trap crop in warm soil. Technically an annual, but one that self-seeds reliably enough to perpetuate itself in a garden bed across multiple seasons. Number 10 is for gardeners dealing with spider mites, which are a pest that chemical controls address poorly, because the most effective chemical miticides kill beneficial predatory mites alongside the pest mites, removing the biological control that would otherwise rebuild naturally. Coriandrum sativum, cilantro, produces volatile compounds in its foliage that have documented spider mite repellent activity, and its flowers, which most gardeners remove to prevent bolting, which is exactly the wrong thing to do from a companion planting standpoint, are among the most attractive nectar sources in the garden for predatory mites, minute pirate bugs, and lacewings, all of which prey on spider mite colonies. Allowing cilantro to bolt and flower is the management decision that converts it from a culinary herb into an active pest management tool, hardy as a cool season annual across all American zones. Plant in spring and again in late summer for 2 flowering windows that bracket the hottest part of the season when spider mite pressure is typically highest in zones 6 through 9. Number 11. The one I told you at the beginning of this video that I held back from including because the mechanism is so counterintuitive it requires explanation before it makes sense. Dill, Anethum graveolens, is a trap crop for tomato hornworm, and the counterintuitive part is this. Tomato hornworm is the larval stage of the 5-spotted hawk moth, which lays its eggs preferentially on dill and fennel over tomatoes when both are present. By planting dill near your tomato bed, you are actively attracting the adult moths that would otherwise lay their eggs on tomato foliage. This sounds like exactly the wrong thing to do. It is actually the correct strategy for one specific and important reason. Dill is also the preferred host of the parasitic wasp Cotesia congregatus, whose larvae parasitize tomato hornworm caterpillars, and which depends on a reliable local population of hornworm hosts to sustain its own breeding population in your garden. A garden with dill has hornworms. A garden with hornworms and dill has Cotesia wasps. A garden with Cotesia wasps has parasitized hornworms that never reach the size at which they cause significant tomato defoliation. The sequence requires the trap part, the concentration of hornworm egg laying on dill, to function, and most gardeners short-circuit it by removing the dill when they see hornworm caterpillars on it, which eliminates the host population that the parasitic wasps depend on. Leave the dill. Leave the hornworms on the dill. Remove any hornworms you find on tomato foliage. Watch for the white egg cases of Cotesia on the backs of hornworm caterpillars. Those are the parasitic wasp pupae, and a caterpillar covered in them is already doomed and is actively producing the next generation of your pest management workforce. This is ecological pest control functioning exactly as it is supposed to, and it requires doing something that feels wrong, tolerating a pest on a sacrificial plant, in order to get something that works. Number 12 is for the root maggot and wireworm problems that affect carrot, onion, and brassica beds across the northern United States, and that operate in the soil, where most companion planting chemistry never reaches. Tagates minuta, Mexican marigold, sometimes called mustard John Henry, is a tall, strongly aromatic annual marigold species that produces root exudates toxic to soil-dwelling pest larvae at higher concentrations and broader spectrum than either French or African marigold. Research from the Rodale Institute's long-term companion planting trials documented suppression of carrot fly larvae and onion fly larvae in plots with dense Tagates minuta interplanting compared to control plots. It grows 4 to 5 feet tall in warm conditions. which makes it more structural than other marigolds and useful as a physical screen, as well as a soil chemistry modifier. Hardy as an annual across all American zones. The strongly aromatic foliage, described as a sharp, pungent, penetrating scent, also has above-ground volatile activity against whiteflies and thrips that adds a second mechanism of pest protection operating simultaneously with the root exudate activity. Number 13 is for the slug problem, which is the pest that most chemical-free companion planting strategies address least effectively because slugs are not insects, and the mechanisms that disrupt insect pest navigation, volatile chemistry, parasitic wasps, trap crops, have limited application to mollusks. Thymus vulgaris, garden thyme, used as a dense ground cover between and around susceptible plants like hostas, lettuce, and strawberries, provides physical disruption to slug movement through its low, dense, aromatic mat of foliage. Slugs navigate primarily through moisture and contact with smooth surfaces. The irregular, scratchy, aromatic surface of a dense thyme planting is not a surface that slugs move through efficiently, and the volatile chemistry of thyme, specifically thymol and carvacrol, has documented molluscicidal activity in laboratory trials published in the journal Pest Management Science. The application requires dense planting. Thyme used as a pathway edging plant 6 inches from a hosta bed is not effective. Thyme planted as a dense ground cover directly surrounding the base of susceptible plants, touching the stem, creates the physical and chemical barrier that reduces slug access to the plant. Hardy in zones 4 through 9 as a semi-evergreen ground cover that maintains its aromatic foliage through most of the year. Number 14 is one whose mechanism operates at the scale of the whole garden rather than at the scale of individual plant protection, and whose companion planting benefit is consequently more diffuse but more durable than most plants on this list. Echinacea purpurea, purple coneflower, is on this list not for any direct pest repellent chemistry, but for what it does to predatory and parasitic insect populations at the garden scale. The flower structure of Echinacea, the prominent spiky central cone surrounded by accessible ray flowers with exposed nectaries, is specifically attractive to parasitic wasps, predatory wasps, lacewings, and soldier beetles, all of which require nectar and pollen sources for adult feeding and which are primary biological control agents for aphids, caterpillar eggs, and soft-bodied pest insects. Research from the Xerces Society's Beneficial Insect Habitat Program documented Echinacea as one of the highest value plants for supporting beneficial insect populations in garden and agricultural settings, with the late season bloom period, July through September, providing nectar at a time when many other companion plants have finished flowering and beneficial insect populations are at their peak seasonal size and most in need of food sources. Hardy in zones 3 through 9. The seed heads left standing through winter feed goldfinches, which in turn are predators of aphid colonies overwintering on woody plant stems. A winter pest control benefit that operates entirely through the food chain the plant supports, rather than through any chemistry the plant produces itself. Number 15 is the last plant on this list and the one that addresses the pest problem most likely to destroy the momentum of a new vegetable gardener before they've had enough seasons to develop the patience that experience provides. Borage, Barago officinalis, is a fast-growing annual with star-shaped blue flowers and cucumber-flavored edible leaves that has 2 documented companion planting mechanisms that make it valuable in vegetable gardens beyond its aesthetic appeal. The first is direct. Borage contains pyrrolizidine alkaloids in its foliage that tomato hornworm and cabbage worm caterpillars find aversive and will avoid when alternative feeding sites are available. Field trials at the Rodale Research Center documented reduced caterpillar feeding damage on tomato and brassica plants grown in close proximity to borage compared to control plots. The second mechanism is indirect. Borage flowers are among the highest nectar producers per flower of any common garden annual, and the open, accessible flower structure makes that nectar available to the complete range of beneficial insects, including bumblebees, honeybees, hoverflies, and parasitic wasps. A barrage plant in full flower on a warm afternoon is covered in beneficial insect activity in a way that is visible and remarkable, and those insects are simultaneously serving as pollinators and as pest management workers throughout the garden, hardy as an annual across all American zones. Self-seeds prolifically enough to perpetuate itself across seasons in most garden settings. Plant it once, and it will be in your garden every year afterward without replanting. Here is how to build a functional companion planting system from these 15 plants rather than scattering them randomly through your garden and hoping for the best. The foundation layer is the predator habitat plants, yarrow, lavender, echinacea, borage, planted at the borders of your vegetable garden in full sun. These plants do not need to be adjacent to specific crops. They need to be within foraging distance of the entire garden, which means within 20 to 30 feet of the beds they are protecting. They are building the predatory and parasitic insect population that manages pest pressure at the garden scale. And that population will move through the entire garden, looking for prey once it is established. The second layer is the chemical disruptors planted as direct interplanting with susceptible crops, garlic with roses and tomatoes, basil with tomatoes and peppers, thyme as ground cover around slug-susceptible plants. These require the close planting precision that the research specifies, within 12 to 18 inches, not in the same general area. The third layer is the trap crops, nasturtiums around brassicas, dill near tomatoes, radish around cucurbits, that concentrate specific pests in specific locations where management is practical. These require the most active management of the 3 layers, specifically the commitment to inspect them regularly and remove pests before the trap crop strategy backfires into a pest nursery. 2 things that the companion planting literature is consistent about that most gardening content consistently underemphasizes. The first is density. Every companion planting benefit in the research literature was documented at planting densities that most home gardeners would consider surprisingly high. 1 French marigold per 2 to 3 square feet, basil interplanted at 1 plant per 2 to 3 tomato plants, nasturtiums in a continuous border rather than as occasional plants. The minimum effective density for most of these plants is significantly higher than what looks comfortable or what typical garden spacing guides suggest. If you plant at too low a density, you are not running the experiment that the research ran, and you should not expect the results the research documented. The second thing is patience across seasons. The most powerful effects in the companion planting research, the nematode suppression from marigolds, the parasitic wasp population building from yarrow and lavender, the soil chemistry modification from African marigold, are effects that build across multiple growing seasons rather than appearing in the first year of planting. A companion planting strategy that is evaluated after 1 season and judged insufficient is almost always a strategy that was not given enough time to build the biological infrastructure it was designed to build. This channel is trying to do something specific that I want to name directly. Give you the complete, honest, research-grounded version of information that exists in accessible form if you know where to look, but that most gardening content either oversimplifies or skips in favor of the version that sounds more immediately satisfying. Companion planting works. It works in specific ways, at specific densities, over specific time horizons, and with specific management requirements. It does not work as magic, as folklore, or as a one-season fix. If that distinction is useful to you, if getting the honest version of how something works is more valuable than getting the version that sounds better, subscribe to this channel now and turn the bell on. Every week, the same standard applies. And before you leave, tell me in the comments what pest problem you are going to address first with this list, what plants you are going to start with, and what your garden grows. Vegetables, ornamentals, fruit, a mix. Because the follow-up video I am building pairs these 15 plants with specific crops and specific pest profiles, and knowing what this community is actually growing tells me which pairings to prioritize. Drop it below. Now go build something that protects itself.